Okay, so we're working on practice test 1, problem number 4, not number 1. And the first thing it asks you to do is write the balanced equation with no physical states for calcium chromate reacting with aluminum metal. Okay, so calcium chromate. Calcium's +2, chromate's -2, so that's good. Plus aluminum. James, what kind of reaction is this? Single replacement, great. Does it react? Would you look it up?
We don't need to
In the activity series, so we don't need to do a problem? No, unfortunately we have to do this problem. So we just assume that it's going to react, all right? Don't look on your activity series. Maybe next year I'll fix that. But, all right, let's say it reacts. Aluminum's going to go with what? Chromate, okay. So aluminum is +3, chromate is -2. All right, so to balance it out, we'll have 2 aluminums, 3 chromates, right? All right, and then plus what? Ca. Okay, is it balanced? No, to balance it, what would you put in front of the calcium chromate? 3, okay, good. And then in front of the aluminum? 2. In front of the aluminum chromate? Just a 1, okay. And then calcium? 3, okay. So now we have it balanced. And then we need to write the name, the correct name of the products. What would AlCr4 be? Good, aluminum chromate. And then what would Ca be? Yeah, you could just write calcium metal, that's fine. Okay, so that's A and B. We have our balance equation, and we have our nomenclature done. Good? Yeah, James, what's up?
Do you have to like put A for the first part and B for the second part?
Yeah, if you can. If you can label everything on your answer sheet, that would be great. It would help me with grading it, definitely. Okay, good. Any other questions? No? Okay. All right, so C, now we're getting into some problems here. It says, given 50 grams of calcium chromate, find the amount of aluminum required for the reaction. So what are we going to do in C? Start with what and then convert it all the way to what? Yeah, we're going to start with the 50 grams of calcium chromate, and then we're going to convert it into grams of aluminum. All right, so let's do that. All right, and we need a molecular mass to do that, which I happen to have. It's 156.08 grams of CaCrO4. Anybody make sure that that's right? Anybody look it up? Is that good? All right, cool. What do we put on the top? Good, 1 mole CaCrO4. And then what's going to go on the bottom? Okay, so moles of CaCrO4. And what are we going to convert this into? Aluminum, right? Moles of aluminum. Okay, how many moles of aluminum? 2, okay, and we get that from looking back here, right? There's 2 moles of aluminum, and then while we're on this page, we're going to need 3 of the calcium chromate. So, 2 aluminum, 3 calcium chromate, and now we go from moles to grams. And it's 26.98, right? All right. Any questions setting that up? No, it's just like what we've been doing, right? Only the problem's specifically telling you exactly what to do. All right, when you do that math, you should end up with 5.76 grams of aluminum. Is everybody okay with that? Okay. Now, look at the next problem. It says you're given 5 grams of aluminum. Is aluminum the limiting reactant or the excess? Okay, if you're given 5 grams of aluminum, what does this mean? What's that?
There's excess.
Not that there's excess, because you're only given 5. What does this 5.76 grams of aluminum mean? Yeah, Andy?
That'd be like the perfect amount.
That would be the perfect amount to use all of this, right? So if we wanted to use all 50 grams of calcium chromate, we would need 5.76 grams of aluminum. Do we have 5.76 grams of aluminum? No, we only have 5 grams, right? So if we only have 5 grams of aluminum, aluminum is the, yeah, it's the limiting reactant. It's run out. The calcium carbonate then is going to be the excess, because we're going to have some of it left over later on. And that's why this problem's a little different than the ones we've been working on, because they're actually giving you some stuff here. They're giving you some more information than normal. All right? Is everybody okay with how we figured that out? Yeah? Okay, so explain it in a sentence. Now, this is the part where you have to come up with it, where you can basically read what it says here. You could say something like, if you used all 50.0 grams of CaCrO4, you would need 5.76 grams of aluminum. You don't have that. You only have 5.00 grams of aluminum. And then aluminum. That's how you know aluminum's the limiting reactant. All right? Your sentence doesn't have to be like that. It can be better, it can be worse. It just has to express that you're going to have this left over because you can't use up all of the calcium chromate. You're going to have some of it left over. All right? Any questions with that? Okay, so now it asks, all right, how many grams of excess are left over? Now, with this, how many grams of excess are left over? Remember, aluminum's a limiting reactant, so you can't just, some people might just think, oh, subtract 5.76 by 5. But remember, that 5.76 doesn't exist, right? We don't have that because we only have 5 grams of aluminum. So that's looking at the limiting reactant. We want to look at the excess. So with the excess, we have 50 grams of it to start with. They want to know how much of it are you going to use, right? Then you can subtract. So what would you start with in this problem? You wouldn't start with the 50 grams. You would start with, what did we start with before when we try to figure it out? The limiting reactant, all right? So what's the limiting reactant? Aluminum, right? And how much of it do you have? 5.00 grams of aluminum. So for this one, you would start with 5.00 grams of aluminum, and then you're going to convert that into grams of calcium chromate, because that's the excess. All right, so let's do it. Because we're going to moles of calcium chromate, moles of aluminum. We have to look back on the balanced equation to figure out how much of each. Aluminum is 2, calcium chromate is 3. Aluminum is 2, calcium chromate is 3. Is that right? Yeah. And then we go 2 grams of calcium chromate. 56.08 grams of calcium chromate, which would give us 43.4 grams calcium chromate. Everybody okay with that? Okay, so what does the 43.4 grams of calcium chromate mean? What does that mean? It's what?
The product produced.
It's not the product produced.
How much you used
How much you used of what?
of CA.
Yeah, yeah, of the calcium chromate, which we're identifying as the excess, right? So this is how much of the excess that's used, all right? So excess used is 43.4 grams. How much excess did we start with? 50. Yeah, we started with 50. So we started with 50 grams of excess given. Minus the excess used is 43.4 grams of CaCrO4. All right, so we subtract them, and then we get 6.6 grams of CaCrO4. If this was given, this was used, this is going to be left over. All right, so 6.6 grams of calcium chromate left over. All right? See how it's similar, but it's slightly different the way that they're wording this stuff. All right, any questions so far? No? All right, then what do we do for F? What would we start with? It's asking how many grams of the aluminum-containing product can be made. We start with?
5 grams of aluminum.
Because aluminum is the?
Limit.
Yeah, exactly. We start with the limiting reactant, that's funny. The limiting reactant, which in this case is aluminum. And we're going to convert this all the way into grams of aluminum containing product, which was the aluminum chromate. All right, so let's do this. 26.98 grams of aluminum. All right, so we have moles of aluminum is 2. All right, how many moles of the aluminum containing product? That was 1, right? Go back. Yep, there's 1, Al2. Right there, 1 mole. And then the molecular mass goes on the top. And it is 401.96. All right, so let's look at the setup. We started with the limiting reactant. We converted it to moles. We took moles of the limiting reactant, converted it into the aluminum-containing product, converted the aluminum-containing product into grams, and that will give us 37.2 grams of the aluminum-containing product, or aluminum chromate. All right, and that's the product produced, just like we've been doing before. Everybody okay with that step? Yeah? Okay. All right, last thing. This is the new part. G. It says, after running the experiment, the actual amount of aluminum containing product formed is found to be 28.6 grams. What is the percent yield? Okay? Now, percent yield is how much of the product was actually found in lab. Like doing the experiment, did you get exactly what you wanted? Did you get less than you wanted? That kind of a thing. So with this, your goal is to get to 100%. All right? So we have to do this part over whole. The part, after running the experiment, the actual amount, that's going to be your experimental, which goes on the top. And then theoretical is what you do from your calculations. That goes on the bottom. All right? So experimental in the lab goes on the top. And then what you theoretically should have come up with goes on the bottom. This is from your calculations. And then this is from the lab. All right? Which we're going to do for our actual lab later this week. Okay, so from the lab they said it was 28.6 grams. From our calculation it was, and you're getting this from here, the amount of product produced should have been 37.2. So not a great job, but okay. 37.2 grams. Figure out our percent. All right, so we divide 28.6 divided by 37.2 times 100, and we should get 76.9%. Which is like a C, right? That's okay. It's not terrible. But we wanted 100, right? So that's how you come up with percent yield.